The way the workshop is designed, that we can have, there are several panels and there are several guest speakers are here. So the workshop is designed in a way that you can come and you can listen and learn it here. You can go back, and if you like one or two other panels, you can go participate over there. So it's the agenda, like from now to 10 p.m. we will be learning about Hadoop. Then there will be 1 hour break, and we will look about data lake and data processing, which is like from 11 to 12. Then after that, there is like 2 hour lunch break where you can go network others here. And then finally, we're going to start the second half of the day, which is like business intelligence and do from 2 to 3. And 3 to 3:30, there is a tea break. And then we will go very last session, like how to develop the best strategy with Hadoop if you are really trying to build up a product. So the objective for this workshop, so the way this workshop is like conceptualized, that business people, those who already have a Hadoop project going on or are already in planning phase, so they can really come, they can learn, they can ask questions. It's like kind of free forum. We can talk, here we are going to give you some product demos. We will be talking about the real life example, like how I really worked in previous company and how we really build different Hadoop products, what our strategy, what we learn, how we fail, how we succeed. So those kind of information will be shared with you. Feel free to ask questions anytime, and because there is a really long gap in between workshop sessions, so you can come talk one-on-one with us. We have our colleagues back. You can go ahead and you can talk with us, and then we can really explain what we have done, and you can learn from our experience. That's one. And then finally, there is what we have here. We have a flyer where feel free to we will be giving to you, so you can fill it out your information. And if you like a one-on-one consultation, we are going to provide free of charge. It means that if you really need to understand what we are doing, or if you have a strategy, you really need to think about it, then we can really help you with. So you can take it, and then once you give back to that, we will be giving you a really just nice, cool-looking T-shirt. You know, so that's we have here, and so now I will go ahead and I will really talk about who we are. It's just like 5 minutes, maybe less than 5 minutes. We will be talking about ourselves, but that's the last time we will be talking about. After that, it's all about Hadoop and how we really need to go. We have a lot to talk. There is a really, we spend really good amount of time working with Fortune 100 companies, and we build really successful Hadoop strategy for others. One second. So if you have any big data related project and you would really want to talk with us, I think we would be love to talk with you, and we will provide as much assistance really needed for that. And so the way we really wanted to talk that, I think Sal, my friend, he already explained what we are really doing, and if you want to say something.
Yeah, so if everyone wants to talk about more about what we're doing, you know, as I've said, each grew in space. So if you guys are somewhere in the adoption lifecycle, either pre-planning, planning, or post-production, you got a wealth of experience in we're obviously building a product that does monitoring, learning, remediation, forecasting, and a bunch of secret sauce stuff to help you run your new platform once it's up and going. So if you like to talk to me or option, we'll have you provide our expertise for free. But obviously at the same time, we're looking to build our valid customer base and show you what we can do, how we also like talk to the new product. Leadership on the side. Thank you.
Yep.
Just a quick question. Are you going to be going through, like, we want to
question like that, we will emphasize all the things we really needed to do. So you think about this workshop is like learning from others. So like as organizers, we are, because we have done that thing, so we can really tell you how we really did. But in the room, if somebody is also available and will say, actually I have done something differently, they really want to chime in, they really want to provide a little information about that, they are also welcome. But we will definitely provide all the technical information you really need. And if we cannot put that information within these sessions, then we can continue our discussion even after the workshop. Okay, so I think that's all we had for the introduction part. And now we will just go ahead. So we have hourly agenda, what we are going to talk within this hour. So here is like the agenda we have, and the agenda is just to streamline the content. It's not like we really need to follow it. There is a lots of content going to be available. We might not be able to talk totally. Because in this forum like that, we might start talking and we might, so if by the end of this hour, if we are not able to finish the content, we can continue later. Or all these slides, what we have here, they will be available through SlideShare. So your email is already with organizers, so they will send you by tonight where these slides are located. So you can go ahead and you can go with slide. Lots of contents in slide just for informational purpose, means you can go back and you can learn later. Here we will just pass through them. Okay, so this is the very first question, because we are here to talk about big data, we are here to talk about Hadoop, we are here to talk about business intelligence. So if you were spending time looking into the industry trends and you were doing your own research, what makes sense here? That in March, today's 2nd April, so like about last week or in last 2 weeks, there were 2 big investments happened related with Hadoop. Anybody can tell who these companies are, who really invested, and because if you are in this room and if you really know these 2 things, I think that make totally sense that you are really in right room. You are really trying to understand something which is really very current, which is really bleeding edge. Anybody in room? Cloudera. And what happened with Cloudera? Who put money? Who is behind that 900 million? Intel. So last week, I think Monday, there was a news that Intel invested $760 million in Cloudera and took 16% equity in the company. And I don't know if you guys know, but Intel already had their own Hadoop. They were trying to push at least last 1 year. Okay, but they were failing miserably, and I think that's what they really look. So they put $760 million in Intel. In Cloudera, and even before that, about 2 weeks back, Cloudera already took $160 million from Google Venture and 2 other VC capital. So they already, if for this $900 million they took for $4.6 billion valuation, that really shows that how Cloudera is really growing. It started in 2008 and we are in 2014. Okay, so that's good. And what about the other next one? Yes, please. I can use mic. Let's see which one is connected. Hello. Hey, have you seen the guy who? I do not say on-off switch. It just and it say number 2. Hello? lots of data.
Well,
Perfect. So now we have another company, $100 million. That's the Hadoop. They really just raised another series of funding. So that just shows that okay, that company, what we are really, everybody is really understanding the power of big data. Everybody really understand that oh, this is something is really very new and it's really needed by the market. So that really shows how we are creating the trend. And how many of you have seen this? And that is called hype cycle. Because that really makes sense that where all these VCs, all these companies, all these startups, they really look into. And they really say that, okay, this is something is what the trends are, where you really need to position yourself. So if you really understand this thing, what is it? This is really created in 2012, Gartner created this hype cycle where it really shows that what is at 2012 was at the peak and what technologies are really going away from trend and what these new technologies are coming. And these dots really shows that which technology might take 2 years, 3 years, 5 years to really organize to come in existence. So big data in 2012 was really coming into, but we are in 2014. And if you look into that 2014, the big data was given about 2 to 5 years, really going to be peak out. And in 2014, now we can really say that big data is really peaking out, like almost billions of dollars is really not invested. So what you have seen the investment in Hadoop platforms, but there is a total separate sections of companies where these companies are really doing. So at the right side, you are seeing there are lots of companies. These are the big data analytics companies, business intelligence companies. They try to see market differently. They try to do something different, which can really separate them from others. There are several companies. I had opportunity to work with few of them. We really built very amazing products. Before joining. Before creating my own startup, my friend Sal, I was working in a company called Platform. How many of you have heard about Platform? Yeah, so a lot. So it means that we really did, and there are several companies where we partner with and we really understand what they are doing, how their product really works. And every company has its own strength and every company has its own weakness where they really, that's where the other companies really try to take advantage from that. So we were really going to talk about it, and at the right side here you see that Amazon, Microsoft, Intel, HP, and IBM, these are the powerhouse who are really putting a lot of money, and they are really rather because they might not have a product within this landscape, but they are pouring their money behind these companies, either upfront or by partnering with them just to be in that space. So because these companies, they already have deep rooted enterprises, working with these companies give them leverage to get more and more customers, to make better significant investment, and then get somebody out. And finally, this is something for very deep. If somebody really would like to know, so this is what within the big data there are several different dimensions where a particular organization or a user can really look into for solutions or products. What you really see here, because I think this is the slide you can go ahead and at the free time you can look into, but this really tells that what is coming in horizon, what is really very hard within that. So you can look into semantic web, you can look into the predictive analytics. So predictive analytics, like there is a company like Amazon, Netflix, they are already doing a lot and they are very successful in that. But there is a new age predictive analytics is coming where modeling can be done just using a very small size of data. Because right now the companies, they are working to create analytics, doing predictive and using existing algorithms and trying to get value or insight out of data, but you really need lots and lots of data to do this. Companies are working on algorithms where you really don't need to have a lot of data. You can really work on a small segment of data and you can still get 80+% of results out of that data. So that is coming really very hard. And then big data is really powering that kind of, I would say, invention. So finally, this is like something we really love to say, that if there is an elephant in your room, you are in the right room. Because that's the time. If you are thinking about Hadoop, if Hadoop is really a solution For you, that it means you are really trying to use a correct solution here. So here is something, because I will be talking almost all day with you. It's better I can introduce myself. So my name is Akash Chauhan. I have currently I'm working with a company called Big Data Perspective, and we have started working since January, and we are still about a few months away when our product will be ready. But we are building one of the kind product, because the way I look into the market, it's almost 15 years. I was working with before Platforma, I was working in Microsoft, and I built the product called HD Insight, Hadoop on Windows Azure. I was part of Windows Azure, where we build data centers and how we optimize the data center. In order to deal with data centers, dealing with almost like 2 million machines at a given time, how we really understood, how we really able to solve the problems. We started with 2 hours, and we narrowed down the problem and resolution within like 10 to 15 minutes. So that's what you are going to learn. And recently, I published a book, and my other book on HD Insight is also coming from Amazon. So if you have time, you can go ahead and take a look. Feel free to ask questions. If you have anything we cannot talk, I will encourage you to contact me later, and then we can really talk it further. So understanding Hadoop. So what we really have here is, there is 2 ways we can understand it. We can go through with slides, and I can kill you just going through slide by slide, and I can really keep telling you, and I think by the next half an hour, 1 hour, I won't be seeing anybody here. By the end of the day, there will be 2 person here. That's one way we can go through. There are slides available, but I can really give you idea at how we really look into how we arrive at a solution. So what I can do here, that I can just make a tally in this group, and I can just see that what kind of audience is here. So based on that, I can really improvise my content. So if I will ask that how many of you in this room really do like almost coding, like you really that's your job. You sit down and code. Okay, so we have okay. And how many we have program manager, product manager. Okay, so we have a few program manager, and how many are the owning the company? You own it, and you are working something like that. Okay, so this is like kind of 50-50. So we have audience who really code, who really spend time, and how many already have a successful Hadoop running, or you are working with Hadoop project. So we have few successful. If like we have 3 person in audience who already have Hadoop running. So what I can do, I can just give you guys like 1 or 2 minutes. If you could really tell everybody in the room that what kind of Hadoop, if you could tell, if you do not want to say, if you don't want to share, it's okay. But if you would like to share what kind of Hadoop projects you are running and what you really do, I think that will be very beneficial. I will start from here, please. Would you like to say, or you
has there?
Please.
There.
So you are using Cloudera, and if I ask what kind of processing you are really doing, data, what kind of data is it? Services. Okay. And here? Apache. Okay. So audit logs. So you are processing audit logs through Hadoop, and you are running Apache. And may I ask?
We're doing Hadoop and Cloudera, and it's healthcare tools around optimization. There's
Okay, so you are using Pivotal and Cloudera, and it's for healthcare optimization. So this just gives you that there are 3 persons in the room, and they are using 3 different Hadoop distributions. The gentleman in this corner, they are using Cloudera. For instance, they have their own Apache Hadoop native, and then somebody is using Pivotal and Cloudera together. And it's not really strange, because when we work with companies, we saw that companies are using 2 or at least 2 Hadoop distribution, because being open source is just to make sure that what is really good for organization. Some companies are running POCs for at least 1 or 2 Hadoop distributions. Okay, So that's really very common, and I think that would be another thing that how you can really do it. Is it really necessary for you to have these two distributions going? So now it comes the topic that how Hadoop saved us dollars and build really new dollar opportunity. So that's where we see that when we were previously I was working with Microsoft, and because lots of things are IP, which I really cannot tell, but a certain what experience we had, how we really built it, I would be able to tell you. So about in 2009, we were building data centers. And at that time, Microsoft has 4 data centers available worldwide. In each data center, we had almost 200,000 machines. And when I talk about 200,000 machines, I'm talking all these machines which are connected through network. It means there could be routers, there could be power supplies, there could be computers, there could be machines which are working as a host machines, and then the tenants are running on those machines. So if we had these 200,000 machines emptying data at any given time in 4 data centers, we had 800,000 machines running at any given time worldwide. And the way we were really collecting this data, because being Microsoft, having SQL Server as our bread and butter, it's a $1 billion business for us. So SQL Server was used to collect all the data from all the machines. And each machine was generating almost in average 10 megabytes of data per day in 24 hours. Now you really think about having 800,000 machines generating 10 megabytes of data, which is really enormous. SQL, by the time we plan for SQL Server, we say, okay, we really need to have a SQL Server, we really need to shard it, we really need to think about it. We plan 2 or 3 weeks to get a SQL Server going, and by the time we get everything ready, we really need to plan for next one. Because the data was coming, and we were, at the same time, the data center team was keep adding more and more machines. So it was like kind of havoc situation where we were trying to understand how the data is coming, how we are really going to store, how we're really going to process, versus the need was really growing. So we planned, and then it was just never working. Sometimes the way solutions were coming, that machines were down, and it was taking almost like 12 hours, 6 hours to 12 hours to figure it out which machine went down. So all the tenants within that machine, they were just like out of service. So I'm talking about in 2009. From 2009 to 2011, we struggled. It was all the time when we were really thinking. SQL Server was doing very good, but it was just not able to keep up the type of information we were really dealing with. It was a lots of, we were investing money left and right. We were trying to build the way our data center was growing, the pretty much same way our SQL Server base was going. We had like hundreds of machines trying to collect data. We were just spending a lots of money bringing these contractors to do analyze all that log for us, to write all this query, figure it out what is really there. And being new kind of data, it was really worrying because we were building cloud. Everybody was using machines really very differently. Machines were going down. For what reason they are going down? It was really very hard for us to determine. By 2011, we decided, okay, Hadoop was already coming, and everybody was talking about Hadoop. We decided to have a internal project, and we said, hey, what about if we start using Hadoop? The good thing with Hadoop was once we put together the cluster, we really did not thought, we didn't think what kind of data we are really dealing. We had a place where we can start dumping our data without even consideration. Versus when we were using SQL, we really have to thought about the schema, what kind of machines, what kind of data is coming out from these machines, because these machines are really being added. So once you drop a machine, and that time we were supporting various Windows versions, being Microsoft, we had ability to understand what kind of information coming out these Windows machines. But still, in order to process, in order to store, we really had to spend 2-3 weeks to understand. Having Hadoop, we cut this 2-3 weeks time just immediate, because when Hadoop was there, we really had a data storage ability, and we just keep adding as we really needed. So we were adding machines, and machines had these hard disks, and we provision these machines. It takes like about 5 to 10 minutes, and without even consideration, data was really being done. So that's one way to look into that. What Hadoop did, it actually immediately solves your problem to understand the data first, and then start thinking how to store. So that's like it's cut down at least your 20% of workload. Now you have data, Because when we were using SQL, the most of our work was done by we were hiring these SQL analysts or SQL guys who really understand SQL and they can do us. So we had a big, large chunk of analysts. We had a lot of like the guys who were doing research in cloud center. They are thinking about how we really need to build the data center, but they were talking most of the time. The SQL guys, I really need that kind of information. Can you help us to get it? So the problem was there is a PhD guy who really has, who is really scientist, who is really dealing with this person who really understand only SQL, and then this person really telling, hey, I really need that kind of data. Can you help me? Now this person is spending time. After 1 hour, the data is coming out, and now this person says, this is not what I was looking. So you see, so there was a lot of a problem. Now what we did, we just cut that thing out. The next step was that these PhD scientists, they are really talking with program manager lead, and there is a group of coders who is sitting in the room. They are understanding what kind of discussion is going on. And once the discussion was done, they sat down, they write the code. There was a few tweak left and right was needed, and by the time we had everything going, now you really not, because we really cut down all that middleman. So all these analysts who really wanted to understand what kind of patterns are where everybody is using data center machines, how machines are failing, because when you have enormous workload in a single switch, how you really try to do networking, because if you are using a network model, is this really working? So what kind of data is really being propagated? Because if you are running one machine, and if you have an 8-core machine, and if you have 16 gig RAM, and if you are running 8 tenants on it, now you have 8 machines running single core on 2 gig RAM. Now, so there are so many permutation and combination. You can think a lot, but you cannot really understand when everything happens in real time. So the way we were calculating, the calculations were going on, it was like enormous workload we were dealing with. But using Hadoop, at least we can say that there was same problem what we were having it, but the way we were solving the problem, to arrive solution to the problems was rather fast. So that's I would say that how, and at the same time, so we cut down a lots of SQL or contract work. We had we just brought a really great engineers to work with us, and we really had a solution. Not only that, we use these solutions, and just after a minor tweaking, we can really arrive to another solution. Then we tweak that another solution, we tweak, and then we build another solution. So when it took at least 2.5 years to build 4 data centers, it took 6 months to add 2 more data centers to it. So by the time when we learned this whole thing, we added 2 more data centers within like 6 months. So that's, you can say that Hadoop really helped. That time we were using internally, we were just trying to understand how we are really doing those things, but that was enormous to understand. There is a lot to go, and as we proceed further, we will learn key things, what we have done in general, and what we have done is strictly following the code line and following the guideline, what it should be done correctly, and where we just throw it out, we say let's do something differently. So now, based on that thought, so at least the essence what I will request you to take, that using Hadoop, there was a way you can really arrive quickly to the solution. There was so many things as traditional store or traditional method where you really have to do were not needed. So that's what Hadoop brought to the table, a very new thinking, a very different way to do same thing what we were doing last 20 years. So what here is, so characteristics of Hadoop is that you can process very large amount of data. You can actually do with databases too, and RDBMS is really doing it. So what's the difference here? So the difference here is that you can actually take this data and you can distribute it on several machines. And then, okay, we can again talk about it that if you look into the high performance computing, or if you look into the parallel computing, that's pretty much doing same thing too. Then the next separation here is that what you can do, yes please.
Can you use your microphone? You're holding it on your hand.
Oh. That's kind of, yeah, okay. So the third is really very important, because what separates Hadoop from others is what you really have a system which is built on commodity machines. If you are using parallel computing, you are using high performance computing, you know that each machine might cost you $30,000 to do it. Here you can just put together a machine with 1 terabyte disk and 128 gig RAM or 92 gig RAM. Now you have a machine available for Hadoop. That's like I'm talking about very high-end Hadoop machine. If you really you cannot afford it, just put a 4-core machine and a 16 gig RAM. That's your and 1 terabyte or half terabyte gig hard disk, and then you have a machine ready for your Hadoop. You can put together your old machine, which is collecting dust, put a few hardware in it, turn it on, and it's ready for it. So that's what separates Hadoop from any other. Like in Microsoft, the thing was that we were upgrading our hardware every year, every 1.5 years. So there were lots of good machines which were just doing nothing. And just for a prototyping, just for testing, we just took all those machines which we gave for PC recycle for no reason. Just because being Microsoft, we have money, we are going to buy new computer. We use those machines put together inside one big warehouse, and we turn it on and we build a almost 120 node Hadoop cluster with junk, which was like garbage for everybody, and it was running successfully. So that's where you can think about Hadoop is a really low cost solution, but you can go very high end too. You can use SSD, you can have really high end memory, their refresh rate is very high. The more money you put, the better response you get, but it's not really needed. So definition of Hadoop, those who are new to Hadoop, this is really very straightforward definition that Hadoop is an open source, Java-based, scalable, fault-tolerant platform for large amount of unstructured data. So that's where you really see, and the data is distributed across machines. And if we look into the key aspects of Hadoop, this is what we really see. And then I always talk about these 4 things because that's where you can think about flexibility, scalability, low cost, and fault tolerant. When it's 2014, okay, and Hadoop almost since 2008, companies were using it, and from 2011, companies start thinking about it. The bigger companies start thinking that I think it is good time for us to look into Hadoop too. And by 2012, there were like clusters populating everywhere. Like there are Yahoo, BP, lots of petroleum companies where these guys are running companies like American Express, Citibank. They are running almost 10,000 node Hadoop cluster, 8,000, 10,000. These are very high-end Hadoop establishments. And companies are actually doing 4 node Hadoop cluster. We were working with prototyping, and then companies have like 3 node Hadoop cluster. But it's really solving their problem. So you can go really very big, or you can go really very small. If you have a data, if companies who already have databases like RDMS where they have their data already sitting. Some companies think that, okay, this is the end of databases for them, let's go for Hadoop. That's one option for them, but it is very much possible that companies are having RDBMS and Hadoop next to each other. And then we will look into further that how the EDW is really coming into in between, and how the companies are really thinking about new way to use Hadoop. And this is something really very important to understand. If you are spending time with Hadoop, this is something a very big differentiator. Can anybody tell about what it means here? The principle is a system to move computation where the data is. Yes, please.
So you begin to analyze the information way upstream, so you kind of catch correlations you may not have thought about structuring your data before downstream.
Please say that again.
So you plug in some sensitivity to begin examining data way upstream, look for correlations you may not even or aware of, at structure. So for instance, in a hospital environment, there's lots of all kinds of different things going on. Measuring how long surgeons watch hands. All of that is data way upstream, being able to look fast at something on top of it and analyze that data there before you can make decisions for instance on that structure.
Okay, so this is little different, and that's where the Hadoop suddenly became a golden boy for everybody. It just became a golden opportunity. Yes, please. So the question the question was that what does it mean a system to move computation where the data is? Okay, may I have your name? Linus? Sorry about that. So the grade was really trying to put in context that you start really thinking about what kind of data you are really going to process upstream. So by the time it really stored, you already have the idea about it. Correct? Yeah. And this is in very technical way. So if you think about the traditional RDBMS, how you really do it, if you have a one single database, just think about a very simple table. You have a list of students. Okay. Now you are writing a single query where say give me the list of students, and its query goes and it really comes back to the result. Next time you write a query, you say give me the list of students from age between this and this. Now query is really running. It's still searching everything and it's really finding who is within that range you have given. Okay. Now you start thinking about a little large scale. Okay. So the processing is that you are really going and you are looking into all the data just to understand how you really want to solve it, how you really want to get the answer about it. Now we go a little more deeper. In this, if you are using parallel computing or you are using high performance computing, the problem was that the data was located at one place and computation was at another place. So when a computation need to go close to data and run the processing on it, sometimes the data has to move. And that was the biggest problem, because if you have a terabyte or petabyte size of data sitting somewhere and now you are really trying to process, you really need to shuffle that all petabytes of data on wire, and doesn't even matter how speedy communication you have. There is a company called Data Direct Network. They give you about $100,000 worth equipment which can push almost like 30 gig data on wire. It's a very proprietary software used by companies like when they do live webcasts like Olympics or these live events. They use that kind of hardware to move that data super fast. But you not everybody cannot use that kind of hardware. So the problem in all that model was that when you really want to do any processing, you are pulling the data, you are bringing to the computation, and with that approach, you are bound. You can build a supercomputer, but you still need to move data over wire, and that's where the limitation. So what Hadoop really does, Hadoop say, okay, I'm not going to move the data, I'm going to bring the computation to the data. Now this changes all the dynamics, because in order to process that whole data, you really have to cut the data in pieces, because otherwise if the data is distributed, then computation has to go in distributed mode. So that's where, if you get to this concept, that's really solved, because that's where the model is. Yes, please. I really can't listen completely.
The example you gave, you mentioned that you had structured data and then you're running the queries on the then going to all the data. So my question is still structured data you are always or you're looking at unstructured data?
So the way it is that when we look into Hadoop, the data can be totally structured or data can be total. So if like there is always an argument that data is always structured. There is some kind of information in it. If I'm dropping a file, then I know it's a file, it has a text content. So there is some structure always associated with that data. The question is, when we talk about the structure, we are really talking about the schema. Do we really understand that very well? Because there could be a possibility when we are talking about the data in tables, data in RDBMS, it's really a person already thought about it. Like when I talk about that the data which I'm really having in this table which has students data, I really know it's a students data. It means there will be student name, where he is, what class, what age. The schema is already built up in my mind.
when I'm really talking about in Hadoop perspective, I might have a file which dump this information, and I really need to write the next level of code which can go and understand what that file. It has a student data, and all the ingenuity, all the learning I'm really putting in my code to understand that data. So the thing is that in terms of RDBMS, the thought process already went when we either had data or we just thought about data. And then we really store all that data there. And now the next person who is really analyzing the data is already driving the wave which already been created early. Versus in Hadoop, we really, as I mentioned, that you really took the data, it's coming out, and you can start dumping. So I can give example. You really want to process something, and you really know how to collect that. So just an example that you write a very simple code where you can scrap websites. You just go, you run you go any web URL, and you just render the data. Now you really say that whatever everything is rendering in my browser, I really want to analyze. You have some money, you have some time, you want to create a new startup. You say, I really want to understand the experience. So you write a very simple curl script which go, and you just get you just created a 3-letter to 10-letter random URL. Just every possible combination you did. Now you are running a curl script. You go URL, you collect all that HTML, and you are saving it. And now all that data, you see, you don't even know that there will be a website which is netflix.com will give you the login page. Versus if you are looking into the amazon.com, now you are getting a whole slew of information about what they are promoting. And if you go google.com, you might see that. So you really don't know what is that. You really know this is a web scraping you are doing. And if you have done that thing for 1 week, now you've collected almost every possible website related data now. It is stored. It might be a few petabytes, might be a few terabytes, you really don't know. But now you have that data sitting in your Hadoop cluster. Now you sit down, you bring some great mind to there, you say, hey, churn this data out, and can you get some intelligence out of it? Versus, now you see that collection part was dumbed down. You just wrote a even you go back, it takes like 10 seconds to write that code. Sorry, 10 minutes, and you start, it's just how long you really want to run that process. So within 10 minutes, you can collect world of information, you can process later. But if we do same exercise and we say we really need to create this RDBMS model. Now you really sit down and start thinking about what will be the structure for this thing. Now you really don't even know, because a website, google.com just give you 2 lines of code because it wants you to search it. Netflix.com asks you to give username and password or log in it, or Amazon or my website, if you go, we are talking about something different. It's a total different idea. So that's where the Hadoop comes. And so once you have that model, actually I don't have idea of time. So, okay, so when it's 10, so let me know. Sure. Thank you. Yes, please.
So just to summarize the principle to make sure I understand it, I think what you're saying is that parts of this data are stored on every machine in the Hadoop cluster, and independently from each machine, they're analyzing that data.
Exactly.
And the computations going on the same machine.
Yeah. So we will learn little later the second part, which is part from 11 to 12. We will be talking about data lake. What is that? It's a new term is coming, but how it's really helping organization. So that's where, so now you got the idea that once we move in this model where computation is really coming close to machines, that really changes the whole dynamics. And that's where it comes. So Hadoop has 2 core components. So as we talk about that, Hadoop is used for data storage, and Hadoop is also used for data processing. So what the data storage layer is called HDFS. It's called Hadoop Distributed File System. So usually you have a file system in every machine. So in order to distribute that data on all machines, a new layer was needed. So a HDFS is a layer which sits on multiples of machines and bind this data together. So for a cluster view, you really look into one single file system which is distributed across hundreds of machines. And when that data is stored, the another layer or another model which is called processing model. So MapReduce method is used to process that data, and that goes back to our previous slide. That MapReduce is a model which takes your processing code and move that every machine individually, let it process there, collect the results, come back, aggregate those results and send back to you. So the storage is HDFS versus the MapReduce is the processing framework. When we talk about same thing conceptually, data storage layer is HDFS and data processing layer is MapReduce. We can talk hours and days about what these things are, but just to summarize this, we will learn HDFS and MapReduce in the session from 11 to 12. Okay, so this is just for learning. So Hadoop is almost like in version 2 now. There are enhancement in HDFS. There are enhancement in MapReduce framework. So we can look into from version 1 and version 2, and even like companies are still stuck with version 1. Version 2 has a lots of really improvement, but those improvements are designed for future. You can still take the advantage of now, but you can, if you do not, you are still very good with version 1. There are some issues which we can talk later, but you can still live with it. So what you are really looking into that organizational, the Hadoop is really decided into 3 main components: Hadoop Common, and then 2 separate components, HDFS and MapReduce. So what Hadoop Common is really bind these 2 pieces together. So the libraries, all that thing is really available to bind these pieces together, and it also has a certain APIs which you really can talk to Hadoop at lower level. Okay, and then if you look into functional component, because HDFS and MapReduce, to make it distributed, so name node is the machine which really takes care of the auditing of the data versus the data nodes where all that data is really distributed across multiple machines. So that's, we will learn that in next session also. And same thing with processing. So when we are trying to do distributed processing, you really need to send the pieces of code on all machines. So the job tracker, which really tracks each processing on all machines, and the tasks are running in these individual nodes. So that's where we call them task trackers. So that's where you can get an idea of name node, data node, job tracker, task tracker, because each job is cut into multiples of tasks, and these tasks are running on individual nodes where the data is. So all the computational is very unique in that. Now we look into version 2, same model. What's going to happen? That Hadoop Common is still there, HDFS 2 is available. HDFS2, the best way to understand, is a federated HDFS. So you have multiple distributed file systems are running. So you can have HDFS like if you are in healthcare and you are using same Hadoop cluster for 2 separate reasons. You are running IT optimization and you are running healthcare. You can actually have 2 HDFS versions, and then you are federated. And if you are using the MapReduce version 2, which is also called as YAR, which then what you can do, that you are using very differently same cluster, and now rather than job tracker and task tracker, now you have the resource manager and node managers. Next, these are, and all that information is available on Yahoo Developer Network. You can go Cloudera or Buttonworks website. They really talk very detailed. Here I am putting this information for reference purposes. So if you look into version 2 functional components, we are again, there is from data storage perspective, that is still going to be called HDFS, where the name node and data nodes are there. And in terms of MapReduce 2 or YAR, we have resource manager, and then we have lots of node managers. Okay, and now if we look into Hadoop ecosystem. Okay, so in Hadoop ecosystem, so that's why you can look into, that really gives you idea that Hadoop core is there, HDFS MapReduce will be there, and then we are having a lots of applications. They are designed for very different purposes. So if you try to store something in Hadoop, so as I mentioned, that if you we collected this whole World Wide Web data as in our Hadoop cluster, and we really want to process, but the person we have, he is great with SQL. He can, if you give him table, he can get everything what we are looking for. What he can do, he can use something called Hive. Hive is something, an application which sits top of Hadoop, is part of Hadoop ecosystem, where it can take that same data and convert into a table where you can run SQL like a statement to process that data. So if you had same thing, now you are using Hive, And Hive took that data which was in your flat file system, created a view which looked like a table. It's a view look like a table. Now you will say, give me the list of URL, which give me the list of all the content which has image on it. It's a SQL statement you made. That SQL statement will go from Hive to code, which will translate it into a new MapReduce job. That statement convert into a MapReduce job. Now that job ran inside will give the results back and you took it. So Pig, HPace, Scoop, Uzi, these are various of application which sits top of Hadoop and create variety of application topics. So you can use one of them or you can build it. And if you look into Spark, so what is Spark? It's a very new look into. It's a incubator project. It's already is very popular these days. Lots of money is really being invested in Apache Spark. If we are not going to talk here, we can. So what Spark is Spark can read data from HDFS, but it doesn't use MapReduce. So there are new ways to use HDFS that because it's a data store where you can dump your data and you can take it when you really need it. Dump now, process later. That will be an objective for our next talk. So that's where you can really look into and see how that is really possible. So what I have. Okay, so I will take 2 more minutes. So now if we look into ecosystem, what else is really being done? Some other things is really going on. So we have something called Cloudera Impala, and then we have something called Hadoop Stage. So what Cloudera Impala is? They still use the data which is on HDFS, but using Cloudera Impala, you can process that data totally differently. It doesn't use MapReduce, and it gives you same query 100 times faster. That's why they claim it. So how that is really faster? You can look into that. And Hadoop Stage is also using similar model, and it's also claimed that we can make same query faster. So those things we will learn. And then we also talk about this Hadoop in cloud, how you can use existing Hadoop in cloud. So I have all that information in my next presentation. So I think, and finally, I will be talking about, so I think we already talked. There are a variety of Hadoop distributions available from Cloudera, from Hortonworks, from MapR, Pivotal. We already have using, and then Intel, we really do not know what's going to happen with their, okay. And you can build your own Hadoop, like somebody is really using it. You can just download the binaries, you can do it. And finally, you can use EMR, which is available on hands-on web service, and I have very good information how you can use it, what is really, and how you can really just using a few dollars. If you want to try Hadoop and you really have $5 in your pocket, how you can run Hadoop. We have information how you could really do it. Okay, so all that information will be available in the next session. So finally, this is my takeaway will be that this is just if you're really looking into Hadoop is really good for you. This is what, if these are your objectives, Hadoop is really a choice for you. Okay, so idea is if you have a semi-structured or unstructured data, if you really want to use commodity machines, you want to reutilize your existing infrastructure, or you really don't have money but you have data. So if you have all those things in your hand and you really want to try Hadoop, Hadoop is really going to be answered to you. And that's my final slide, that Hadoop is here to change how data is really stored and processed. HDFS and MapReduce. Think about data processing and data storage. Okay, and Hadoop is not a replacement for RDBMS. It's actually used as a complementary to it. And finally, that if you understand the enterprise data warehousing, how Hadoop is changing enterprise data warehousing, how Hadoop is really taking pieces from enterprise data warehouse like Teradata, $1 billion company, you know, how they really understand Hadoop and how they really think that Hadoop could be a threat to them, or Hadoop is just a complementary system for them which is really going to help them. So these are the things we will be looking into our next session, which is data lake, how data is really processed. and that will be from 11 to 12. So now we have 1 hour. Feel free to go network. If you have any questions, we are here. We can talk about it. And if you have time, we can provide you this paper. Feel free to provide your information, and it also has an option where after this conference we can have one-on-one talk. If you provide that information, we will definitely contact you based on what time frame you want us to contact, and we can really explain what we are doing and how we can help you. So thank you so much, and I will see you guys back at 11. Thank you.